Today, I'm here to explain about this question. This might look easy for you, but actually it has two problems. First one is this equation has both sine and cosine. Let me give you an example. If the question has all sine, like sine square x plus 4 sine x plus 3 is equivalent to 0, if you substitute sine x into t, you can just make this equation into just look like quadratic equation. This. If you just factor it, you can easily solve this equation. But if it has both sine and cosine, it makes it so harder to solve it. That's the first problem. And plus, it has cosine 2x and sine x. Let me give you an example. If the equation is like cosine 2x plus 3 cosine x plus 3 is equivalent to 0, even though you try to substitute cosine x into, for example, s, it's pretty hard to express cosine 2x using s. That's because it's totally different function. So, what do you have to do? What I would do is first you try to convert cosine 2x into cosine x something. Let me try it. To convert cosine 2x, I want you to remember some and different identities. Do you remember that? I explained it in previous video, but let me explain it again. Some identities is, for example, cosine a plus b is equivalent to cosine a times cosine b, negative sine a times sine b. In this case, it says cosine 2x. So let me write it like cosine x plus x is equivalent to cosine x times cosine x negative sine x times sine x. Then you can just simply write cosine 2x is equal to cosine square x negative sine square x. But still, it has both cosine and sine. So let's make it have only sine or cosine. So on the right side is sine in this equation. So let's make it have all sine. To convert it, I use this equation. Sine square x plus cosine square x is equal to 1. Then if you move this sine square x into right side, you can create another equation, which is cosine square x is equivalent to 1 negative sine square x. Then now we can easily replace cosine square x with 1 negative sine square x. 1 negative sine square x, negative sine square x, which is 1 negative 2 sine square x. So it's done. Now you can replace cosine square x here with 1 negative 2 sine square x. Then let me substitute sine x into t. The equation is going to be 1 negative 2t squared is equivalent to 2t squared. It's just quadratic equation. So let me move this one is right side. 1 is equivalent to 4t squared. Then let me just flip it out. 4t squared is equivalent to 1. Then divided by 4 for both sides. T squared is equivalent to 1 over 4. Then t is plus minus 1 over 2. Again, the t is actually sine x. So let's back sine x here. Is equivalent to plus minus 1 over 2. Then let's find the value of x. This is actually special angle because sine x is plus minus 1 over 2, which is like that, 2, 1, square root of 3. So the angle here is pi over 6. If you have no idea about it, please check out my previous video. I don't explain it like today. Then x is, and actually the range of x is here. So the value of x is pi over 6 and 5 pi over 6 and also 7 pi over 6 and 11 pi over 6. That's all. But let me summarize it again. So the important thing is you try to have this equation. You have to try to make this equation have only sine and cosine. And also, you can't have cosine 2x and cosine x in one equation. It's pretty harder to solve it, so it's better to convert it like this. So let me summarize double angle identities again. Actually, you don't need to remember much. What you have to remember, what you have to memorize is sum and difference identities. And this equation, sine square x plus cosine square x is equivalent to 1. If you know sum and difference identities, you can just easily find double angle identities like this. Then if you know this equation, you can just convert this equation into all sine or all cosine. Example, it's going to be 1 negative sine square x if you substitute cosine square a with 1 negative sine square x. And also you can convert it sine to cosine square x negative 1. But you don't remember these three. Again, what you have to remember is these sum and difference identities and also this equation. Okay, and besides, let me teach you another double angle identities, which is sine a plus b. What it's going to be? It's going to be sine a cosine b plus sine cosine a sine b. So if it's going to be sine 2a, it's gonna be sine a times cosine a plus sine a times cosine a, which is 2 sine a cosine a. This is so useful too. So it's better to memorize this one as well. But again, you don't need to memorize it. You can just make this equation from here, from sum and difference identities. That's all.